Okay, so problem number 1, we have carbon tetrachloride having a specific gravity of 0.92 flows through a 200 mm diameter pipe at a velocity of 2 meter per second. Compute the volume of flow rate in cubic meter per second. So, at given na 200 mm diameter, sa daan siya i-convert into 0.02 meters, and then the volume is 2 meter per second. So, pagpangitan nato sa volume flow rate, we have a formula Q equals area times velocity. So, ang formula sa area is pi over 4, then ang D nato is ang 0.02 meter squared, then times 2 nga meter per second nga velocity. So, the answer is 0.063 cubic meter per second. Okay, so for problem number 2, we have a problem. Water flows in a 400 mm diameter pipe at the rate of 600 liter per second. The pipe has a length of 60 meters. Compute the head loss using Darcy-Weisbach formula with F equals 0.028. So first, ato imutang ang mga given. So we have a diameter of 400 mm diameter. So convert it into meters. So nahimo siya 0.4 meters. And then the next one is the flow rate, which we have 600 meter per second, and convert into cubic per meter per second is 0.6 cubic meter per second, and we have the length 60 meters and F 0.028. So formula sa Darcy-Weisbach is we have head loss equals 0.0826 FLQ squared over D raised to 5. So ato lang ni siya ikuan pang-input ang atong mga given. So we have ang F 0.028, then ang length nga 60 meters, then ang flow rate nga 0.6, then ang diameter nga 0.4, then to calculate it, so we have the answer of head loss equals to 4.979 meters. Okay, so for problem number 3, we have an open channel is to have a discharge of 37 cubic meter per second and average velocity of 1.5 meter per second. So find the depth of the trapezoidal open channel using the most efficient section. So first is ato yung ang given. So we have a discharge na 37 cubic meter per second and then the average velocity of 1.5 meter per second. And then alam ka sa solution. So ang pagpalitan natin sa cross-sectional area, so we have A is equal to discharge over velocity. So naman discharge na 37, then ang velocity na 1.5, so divide. So we have ang answer ta of 24.667 square meter. So if mag-use na ta sa using the most efficient section, so mag-draw ta diri og trapezoidal na open channels. Ato ni siya kanon. So natay 60 degrees, then ang depth na ato gipahita. So first, makita ta sa area, kay naman na form ng tulo ka triangle, so 3 times 1/2, then ang y squared sine 60 degrees. So, ang ato na po nga cross-sectional area, which is 24.667, ibutang to ari, and 3 times 1/2, y squared din sine 60. So, ato ni siya i-calculate, so nakakuha ta ang y is equal to 4.3576 meters. So, di ba, ato yung pangita is ang depth. So, ato na mo na siya ang depth, d is equal to y sine 60 degrees. So, ato nakuha din na y, which is 4.3576. Ato lang na siya i-input. So, to calculate everything, so we have, naka-answer ta, ang depth is we have 3.774 meters. Okay, so we have problem number 4. Water flows through a pipe that enlarges from 130 millimeter diameter at A to 240 millimeter in diameter, at which is 5 meters above point A. The pressure at point A and B are 60 kilopascal and 45 kilopascal, respectively. So what is the velocity of flow A? So first, we have a drawing here. So, mo na siya ang point A and then ang point B. So, we have ang diameter sa point A is 130 millimeters and then ang iya pressure is 60 ppa. And then point B is 240 mm sa diameter and 45 kilopascal sa pressure. And then, ato lang siya i-convert ang 130 mm into meters, so 0.13 and 0.24. And then from point A to point B, ang iyang depth is 5 meters. So, energy equation between A and B, neglecting head loss. So, we have EA equals to AB. So, EA is we have BA squared over 2G plus PA over unit weight plus GA equals BB squared over 2G plus PB over unit weight plus ZB. So, we have there is a BA squared over 2G. So, pwede na ito siya mahimo nga 8Q squared over pi squared G BA raised to 4. And then same PA over unit weight. Then, ato lang i-press out ang ZA kay wala man tayo height na nilagay sa A. And then, 8Q squared pi squared G BB raised to 4 plus PB plus ZB. So, input. So, 8Q squared pi squared. Then, the gravity is 9.81. Then, the diameter of A, which is 0.13 raised to 4 plus PA, pressure A is 60 kilopascal over unit weight na 9.81. Cross out na lang ang Z because we have no length in ZA equals from VB 8Q squared pi squared, then the gravity 9.81, then the diameter of DB, which is 0.24 raised to 4 plus pressure B, which is 45 over 9.81 plus ZB, kani length is 5 meters. So, to calculate that, makakuha tag answer sa Q, which is 0.1146 cubic meter per second. But, the question is, what is the velocity of flow A? So, the formula of velocity of A is equal to VA is equal to Q over A. So, na naman tayo nakuha nga 0.1146 ng Q. So, input here. And then the area sa point A, which is we have pi over 4. Then, ang area diameter na A, which is 0.13. Input here, 0.13 raised to 2 is equal to calculate that, VA is equal to 8.634 meter per second. Okay, so for problem number 5, a column of mercury produces 800 kilopascal. What is the equivalent height of water column? So we have a solution. So ang ato pressures, we have 800 kilopascal. So equivalent height of water or the pressure head, so the height of water equals the pressure over unit weight. So we have a pressure of 800 kilopascal and the unit weight of water is 9.81. So divide, so 800 divided by 9.81 is equal to 81.55 meters. Okay, so for problem number 6, water flows freely from the top of a 20-meter high building. If 0.5 cubic meters of water flow in 2 seconds, compute the force as it hit the passers-by below. So first is ato input and given. So we have height of the building is 20 meters, the volume of the water is 0.5, and the time is 2 seconds. So ato solution ani, we need to use the equation for dynamic force, which is FD is equal to the density of water times the flow rate and times the velocity of flow. So, naman tayo density sa water, which is 1,000 kg per cubic meter. So, constant na siya. And then, papalitan natin sa flow rate, which is Q. Q is equal to V over T, which is ang V na to, which is volume. So, only 0.5, and then the time na 2 seconds. So, 0.5 over 2 is equal to 0.25 cubic meter per second. So, muna ito siya to flow rate. Next is pakitaan na to ang velocity of flow. So, we have V is equal to square root of 2GH equals square root of 2 times the G, which is 9.81 gravity, and then the height of the building, which is 20. So to calculate it, so we have 19.81 meter per second ang ato velocity of flow. So if makita natin dali sa dynamic force, which is FD is equal to density of water, which is 1,000, so input 1,000, and then the Q is 0.25 times, then the velocity of flow, which is 19.81. So to calculate everything, nakakuha tag answer na 4,951 Newton. Okay, so for problem number 7, water flows at the rate of 5 cubic meters at a total head of 10 meters. Obtain the horsepower in the flow. So given, we have the flow rate 5 cubic meter per second, and then the total head, which is 10 meters. Then the solution is we have P is equal to Q times the unit weight and then the total head. So P equals, which is ang Q na to 5, And then the unit weight is 9.81, and then the total head 10. So 5 times 9.81 times 10 is equal to 490.5 kilowatts. So ang ipanitan dere is obtain the horsepower in the flow. So ato ni siya ang kilowatts ato i-convert into horsepower. So in 1 HP we have 0.7457 kilowatts. So i-cross out ang cross out. So 490.5 divided by 0.07457, we have the 657.8 horsepower. Okay, so for problem number 8, a closed conical tank has a bottom of radius of 40 cm and is 90 cm tall. The tank contains 0.058 cubic meters of water. What is the volume of the tank? So this is the figure of a closed conical tank, and then we have the radius here 40 cm, and the height 1 and height 2, and overall height is which we have 90 cm. So for the formula on how to get the volume of the tank, we have volume tank equals 1/3 pi r squared times the h. So volume tank equals 1/3 pi, then we have the radius 40 cm. The 40 cm convert it into meters, so we have 0.40 raised to the power of 2 times the 0.90, which is the 90 cm tall. So all over that, we have 0.1508 cubic meters. So convert it into liters, the answer will be, the volume of the tank will be 150.8 liters. So at problem number 9, at a certain elevation above sea level, a mercury barometer reads 700 millimeters. Evaluate the atmospheric pressure in kilopascal at that level. So for the solution, we have atmospheric pressure at that level is the P atmosphere is equal to the unit weight of mercury times the height of mercury is equal to 9.81, then 13.6 the specific gravity of mercury times ang 700 mm, convert into liters, which is we have 0.7. So multiply, so we have the answer of the P atmospheric pressure at that level is equal to 93.391 kilopascal. Okay, so for problem number 10, a rectangular channel 2 meters wide carries 2.2 cubic meter per second of water in subcritical uniform flow at a depth of 1.0 meter. Compute the specific energy. So we have a figure here, the A, then A minimum, then times the height, then the vertical depth, and then we have the first depth is 1.0 meter. So our first formula is Q is equal to AV, which is Q, the 2.2 meter equals the area is 1 meter times 2 meter, and then the velocity. So to calculate it, we have the velocity to have 1.1 meter per second. Then the next is, we have the formula E equals to V2 squared over 2G plus D. So we have the V is 1.1 squared over 2 times the G is gravity, 9.81, plus the depth is 1.0 meters. To calculate everything, we came up the answer. E is equal to 1.0617 meters. Okay, so for problem number 11, a circular aluminum, which is M equals 0.020, channel, 2.44 millimeter diameter, has a frog number of 0.50 in uniform half full flow. Compute the critical velocity. So this is our figure. We have the radius of 1.22, and then the B is equal to 2.44. So first, we have the formula. Vertical velocity equals the square root of GA over B. And then first, we have to compute the area. So area is equal to pi r, which is 1.22 squared over 2. So to calculate that, we can come up the area is equal to 2.34 square meter. And then the B is 2 times the radius 1.22, and then we have 2.54 meters ang sa B. So, for the critical velocity, ato lang siya i-input ang tanan. So, which is G is gravity, 9.81. And then the A area is 2.34 meters square meter all over the B, which is 2.44 square root. And then we have the answer for critical velocity, 3.07 meter per second. For number 12, water is to flow at a flow rate of 30 cubic meter per second in a concrete channel shown through a total drop at 4 meters. Find the length of channel for normal flow. Use S equals 0.000746. So for the solution, we have the formula S equals H over L. So which is an S, we have here, it is given 0.000746. And then the H is ang total drop at 4 meters. So, ang ipakita nato is find the length. So, over L. So, to calculate everything, so we can come up the answer. 5,000, the length is 5,362 meters. So, for number 13, a rectangular channel, 9 meter wide, carries a 7.65 cubic meter per second when flowing 0.90 meters deep. Compute the specific energy. So, this is the rectangular channel, which is we have 9 meters width and 0.90 depth. So, first, we will compute the velocity. So, we have the formula, Q is equal to AV. So, which is the Q, we have 7.65 cubic meter per second equals, so this is rectangular, so 9 meter times 0.90 V. So, we have the velocity of 0.94 meter per second. And then, we have the formula to compute the specific energy. Specific energy equals D plus V squared over 2G. So, we have the D, which is 0.90, and then the velocity, the 0.94 squared over 2 times 9.81. So, the answer will be, the specific energy is equal to 0.945 meters. Okay, so for number 14, for constant specific energy of 5 meters and a channel width of 3 meters, compute the critical depth. So we have the solution here. So we have the specific energy, which is 5 meters, and then the formula is DC equals 2/3 H, which is our H is the specific energy. So I multiply by 5, so 2/3 times 5 is equal to the critical depth equals 3.33 meters. So for number 15, an orifice of area 25 square centimeter in vertical plate has a head of 1.3 meter of oil. Specific gravity is 0.29. It discharges 6,192 Newton of oil in 88.8 seconds. Trajectory measurements yield XO equals 214 meters and then the Y equals 1.37 meters. Compute the coefficient of velocity. So we have a figure here, the oil which has 1.30 meters and then the Y is 1.37 meters and then the X is 2.4 meters. So first is we will solve the coefficient of velocity. So we have the discharge equals the 6,192 Newton over the unit weight, which is 9,810, and then the specific gravity 0.89, and then multiply by the time 88.8 seconds. So we have the answer of 0.008 cubic meter per second. And then another formula for the Y is Y equals 1/2 JT squared, which is on Y, is 1.37 equals 1 times the gravity, which is 9.81 over 2 times T squared. So the answer for T is equal to 0.528 seconds. And then the next one is the X. X equals VT, which is the X is 2.4 equals V times our time, 0.528. So, multiply all over that, the velocity will be 4.541 meter per second. So, the next one is, we have the formula, V equals the coefficient velocity square root of 2GH. So, we have the velocity 4.541 equals the coefficient of velocity square root of 2 times 9.81 times 1.13. So the answer for the coefficient of velocity is 0.9.61. For number 16, a 75 millimeter diameter orifice discharges 0.023 cubic meter per second of liquid under a head of 2.90 meters. The diameter of the jet at the vena contracta is found by calibering to be 66.25 mm. Calculate the coefficient of discharge. So we have the formula Q equals CA square root of 2GH. So we have the discharge 0.023 equals C. The area is pi over 4 times 0.075 squared in the square root of 2 times 9.81 times 2.90. To calculate that, we have the coefficient of discharge equals to 0.69. Okay, so for number 17, a jet having a diameter of 50 mm and a velocity of 15 meter per second is deflected through an angle of 60 degrees by a curved vane. Determine the x component of the force exerted if the vane is fixed. So we have the solution here. So this is the vane. We have the V1 equals 15 meter per second, and then the angle which is 60 degrees, and then the Ry and Rx. So first, we need to compute the flow of rate. So Q is equal to AV equals pi over 4, which is a D. The 50 mm, convert it into meters, 0.05 squared. Then the velocity of 15 meter per second. So to calculate everything, so we can came up the answer of 0.029 cubic meter per second. And then the next is we have the summation of Fx equals Q times the unit weight of water over gravity times V2x minus V1x. So negative Rx equals the Q times the unit weight of water over the gravity, then times V2x minus V1x. So we have the Q, which is 0.029, and then the unit weight of water is 9,810. All over that, the gravity 9.81 times the 1,500 sine 60 degrees minus 50 is, we can came up the answer, 217.5 kilonewton. Okay, so for number 18, a jet of water flowing horizontally is deflected by a 90 degrees curved vane. If the water jet is a diameter of 38 mm and a velocity of 7.8 meter per second, compute the horizontal component of the force required to hold the vane in place. So we have the V1x equals 7.8, then the V2y equals 7.8. So first, we need to find the flow of rate. So Q equals A1 V1 equals pi over 4 times 0.038 squared times 7.8 with the velocity equals 0.00885 cubic meter per second. So the next one is we have the formula. Summation of Fx equals the Q equals the unit weight of water over that gravity times V2x minus V1x, which is negative Rx equals the Q, which is 0.00885 times the unit weight of water, which is 9,810 over the gravity 9.81 times 0 minus 7.8. So we can came up the answer of Rx equals 69.03 Newton. So for number 19, a 50 mm diameter horizontal jet of water strikes a flat plate as shown. Determine the jet velocity if the plate is stationary. So this is the figure. We have the V1 and then the 80 Newton. So for our formula, we have F equals density times the area times the V1 squared. So we have the force, which is 80 Newton, and then the density of water is 1,000 times the area of pi over 4 times 0.05 squared V1 squared. So we have the answer for the V1 equals 6.38 meter per second. For number 20, a horizontal 100 millimeter diameter jet of water with mass equals 300 kilogram per second strikes a vertical plate. Determine the force needed to hold the plate stationary. So this is our figure. So So for the solution, we have the formula. Force equals the density times the area times the velocity. And then force is equal to mass. So we have the mass, which is 300 equals the density of water, which is 1,000. And then the area is pi over 4 times 0.10 squared v. So we have our velocity. V equals 38.20 meter per second. For number 21, a nozzle of 50 millimeter diameter delivers a stream of water at a velocity of 65 meter per second perpendicular to a fixed plate. Calculate the force on the plate. So this is our figure. We have the velocity 65 meter per second and we have the force is perpendicular to the plate. So we have our formula. Force equals to density times area times dV squared. So F equals density of water, which is 1,000. The area is pi over 4 times 0.5 squared. And then our velocity, which is 65, multiplied by 65 squared. So we have the answer for our force. Force is equal to 8,295.77 Newton. A vertical jet of water through a nozzle supports a load of 150 Newton. The velocity and diameter of the jet at the nozzle tip are 17.46 meter per second and 3 centimeter. Find the distance of a load from the nozzle tip in meters. So this is our figure here. We have the 150, then our height. So this is our formula. First, we need to find the discharge. So Q equals area times velocity. So we have the area, pi over 4 times the diameter of 0.03 squared. And we have our velocity, 17.46. So we came up the answer for the flow rate. So Q is equal to 0.0123 cubic meter per second. And then for the next formula, we have F equals the Q times W over G times V2 equals, so we have our Q, 0.0123 times the weight for the water is 9,810 times V2 over 9.81 times 1.50. So we have the answer, 12.54 meter per second. So another formula for how to find the V2 is V2 squared equals V1 squared minus 2GH. So we have our V2, 12.54 squared equals our V1, 17.46 squared minus 2 times 9.81. So we have the answer for the height is equal to 8 meters. So for number 23, the diameter of a sewer pipe is 500 millimeter. Coefficient of a roughness is 0.012 and slope of energy gradient is 0.002. Compute the depth of water in the pipe if the discharge is maximum. So this is our sewer pipe and this is our diameter, which is 0.938D, and then our theta. So for the solution, we have D is equal to 0.938D. So D is equal to 0.938, which we have a 500 millimeter diameter. Convert it into meter, we have 500. So multiply that, we have D is equal to 469 millimeter. So for number 24, the 50 degrees triangular shown has a flow rate of 16 cubic meter per second. Using N equals 0.018. Compute the critical depth. So this is our triangular. So we have the theta, which is 50 degrees, and then the y is for the slope, and then the critical depth. So we have our solution. So first, we need to find the x. So tangent 50 degrees equals to the critical depth over x. So where x is equal to 0.839 dc. And then next, we have to find the area. So where area of the triangle is 1/2 base times height. So A equals to 1 times 2 is 2, times we have 2x, so 2x times the depth or the critical depth over 2. So the answer for the area is equal to 0.839 bc squared. And then for the B equals 2x, so we have our x here, which is 0.839 dc. So we only need to substitute for the x in B is equal to 2x. So 2 times 0.839 DC is equal to, where B is equal to 1.678 DC. So, and the next one is we need to find the critical conditions, which we have a formula of Q squared over the G, or the gravity, equals A cubed over B. So, we have our flow rate, which is 16 cubic meter per second over G, which is 9.81, and our A, which is 0.839 DC squared raised to power of 3 all over 1.678 DC, which is our B. So, to get the answer of DC, we have of DC is raised to the power of 5 equals 74.14, and then to get that answer for the critical depth, we came up the answer 2.37 meters. So for number 25, a rectangular channel has a bottom width of 3 meters. The channel has to carry 6.5 cubic meters. So assume n equals 0.012. What is the depth of the channel to have an optimum section? So this is our rectangular channel. We have dB for the base equals 2D, and our depth, which is D. So solution, we need to find what is the depth. So B equals 2D. So we have our B, which is 3 meters, equals 2D. So we came up the answer of D, which is D is equal to 1.5 meters. Okay, so for number 26, a cylindrical water storage 12 meters in diameter and 8 meter high is filled through a 100 millimeter pipe carrying a velocity of 40 meters per second. How long will it take to fill the tank? So this is our tank. We have our height, which is 8 meters, and our diameter, which is 12 meters. So for the solution, we need to find the discharge first. So we have the formula, Q equals the area times velocity. So the area is pi over 4, and we have our diameter, which is 100 millimeter. Convert it into meters, so we have 0.10 raised to 2 times our velocity, which is 40. So to calculate everything, we came up with the answer, Q equals 0.314 cubic meter per second. So the question is, how long will it take to fill the tank? So we need to find the time. So the formula for the time is time equals volume over Q. So T equals, which is the volume, pi R, which is 12 divided by 2, which is 6. So pi times 6 raised to the power of 2, then times 8 with the height, over dq, which is 0.314. So divide all over 3.14. So the answer will be 2,881.5 seconds. So the answer will be converted into meters. So we convert it into minute. So the answer will be 48.025 minutes. For number 27, a 60mm diameter siphon is drawing water from an oil reservoir as shown. If the head loss from 1 to 2 is 1.40 and from 2 to 3 is 2.30 meters, find the velocity of flow at 3. So this is the reservoir. So from 1 to 2, we have 1.4 meters, and then from 2 to 3, we have 2.3 meters, and then we have the oil and has a specific gravity of 0.85. So we have our formula, V1 squared over 2G plus P1 over the unit weight plus Z1 equals from to flow 3 months, so V3 squared over 2G plus P3 over unit weight plus Z3 plus head loss. So we don't have velocity, so cross out. We have the pressure, cross out. And for the P3, cross out ang pressure. And then the Z3, cross out. So we only have Z1. From the 1 to 2, we have 4.2 equals V3 squared over 2G plus the 1.4 plus 2.3 na head loss. So we have, the answer will be V3 is equal to 3.13 meter per second. For number 28, the horizontal line fitting in the figure splits Q1 into 2 equal flow rates. At section 1, Q1 equals 4 cubic feet per second and P1 equals 20 pc. Neglecting losses, compute velocity at 2. So this is the horizontal line. So we have the P 6 inches, and then the D is equal to 4 inches, and the D for B is 3 inches. So for the solution, we have the formula Q2 equals 1 half Q1. So here we have the Q1, which is 4 cubic feet per second. 4 divided by 2 equals to 2 cubic feet per second. So, muna na to Q2. First, the next na itong buhaton is we need to find the velocity. So, V2 equals to Q2 over A2. So, we have the Q2 here, 2 cubic feet per second over the area, pi over 4 times 4 over 12 squared. So, the answer will be V2 is equal to 22.92 feet per second. For number 29, a 60 millimeter diameter pipe as shown contains glycerin at 8.5 cubic meter per hour. Compute the velocity of glycerin of the following inside the pipe. So we have at A, we have a 2 atmospheric pressure, and for number 3, we have 3.8 atmospheric pressure, and our height is 12 meters. So we need to find the velocity. So we have the formula V equals Q over A. So we have our Q, which is 8.5 cubic meter per hour, then change into seconds. So 3 over the 8.5 over 3,600 all over pi over 4, and our D, which is 60 mm, convert into meters, 0.06 squared. So the answer for velocity of the glycerin is 0.835 meter per second. So for number 30, a circular conduit flowing half full carries 14.17 cubic meter per second at 3 meter per second. If n equals 0.013, compute the Froude number, then use the D is equal to 3.47 meters. So this is the circular conduit. We have the radius and the B. So we have first that we need to find is the area. So pi times the 3.4, which is our D, squared over 8. So area is equal to 4.728 square meter. And then our B is, this is our diameter, which is the B is equal also to diameter, which is 3.47 meter. So we need to find the Froude number. So the Froude number's formula is, Froude number is equal to V over the square root of G, or the gravity, times area over B. So substitute the given. Froude number equals V, which is the velocity, 3 meter per second, the gravity, 9.81, and the area, which is 4.728 over 3.47, the square root. So the answer will be F is equal to 0.82. For number 31, a semicircular corrugated metal has N equals 0.026 channel must transport 2.4 cubic meter per second. A distance of 1,000 meters with head loss of 2 meters. Compute the radius. So, kanimo ni siya ang semicircular corrugated metal. So, we need to find the radius. So, first is we need to find the S or the slope, which we have S is equal to 2 head loss, 2 over length, which is 1,000. So, 2 over 1,000. The answer will be S is equal to 0.002. So, the question is we need to compute the radius. We have the hydraulic radius equals to radius over 2, which is R equals 0.5 R. Then, we have the formula Q is equal to area times the hydraulic radius raised to the power of 2/3 times the slope raised to 1/2 over N. So we have Q, which is 2.4 cubic meter per second. Area is pi R squared over 2. Then R, which is 0.5 R raised to the power of 2/3 times the S, which is 0.002 raised to 1/2 over N, 0.025. So the answer will be the radius is equal to 1.121 meters. For number 32, a stream having width of 4 meter carries flow rate of 14.88 cubic meter per second with a velocity of 5.18 meter per second at an initial point. Compute the Froude number. So we need to, here we have the solution. Small q is equal to 14.88, which is the flow rate, over 4. This is the width. So 14.88 over 4 is equal to q is equal to 3.72 cubic meter per second. And then we need to find the d1. So q, we have the formula. Q is equal to a1 b1. So we have the q, which is 3.72 equals 1 times d1. Then the velocity of 5.18 meter per second. So they came up the answer of d1 is equal to 0.718. But we need to find the Froude numbers. So the Froude numbers formula is Fn is equal to v over square root of gravity times d, which is the velocity is 5.18 meter per second, square root over square root of the gravity, which is 9.81, times d, which is 0.718. So we came up the answer. Froude number equals to 1.95. For number 33, for a flow rate of 9 cubic meter per second on a rectangular channel shown, having a width of 3 meters, where a hydraulic jump occurs. So use d1 equals 1.95, then compute the velocity at point 2. So this is the figure we have shown. This is 3 meters, then the d1, and then the d2, then we have v1 and v2. So our solution, or the formula for this problem that we need to do, is we have q is equal to a2v2. We have q, which is 3, equals an a2, which is 1.95 times 1, v2. So to answer that, we came up the answer of v2, it equals 1.54 meter per second. Okay, so for number 34, in the figure shown, area 1 equals 100 meter by 2 meter. Area 2 is 30 meter by 10 meter. Area 3 equals 200 meter by 3 meters. And for the slope is 0.0018. And then N1, or the roughness coefficient, is 0.03. N2 is 0.020. N3 is equal to 0.03. So determine the type of flow, then use the discharge equals 4,449.42 cubic meter per second. So this is our figure, which is 100 plus 30 plus 200, and then we have the height, which is 3 meters, then 7 meters, and then 2 meters and 8 meters. So solution, we need to find first the area. So we have area 100 by 2, so 100 times 2 plus 30 times 10 plus 200 times 3. So we have the area equals 1,100 square meter. And then for the base is we have 100 plus 30 plus 200, so equal to 330. Next is we need to find the velocity. So we have the formula is Q is equal to AV, which is we have the Q given 4,449.42 equals the area of 1,100 times velocity. So to calculate that, we came up with the answer 4.04 meter per second. Lastly, so determine the type of flow, we need to use the formula of the Froude number. So we have the formula, Froude number equals velocity over the square root of gravity times the area over b. So we have velocity, which is 4.04, and then over the square root of gravity, which is 9.81, and then the area, which is 1,100 square meter, over b, which is 330. So the answer for the Froude number is 0.71. But the question is determine the type of flow. So 0.71 is less than 1. So the flow is subcritical. So for number 35, a circular aluminum channel 2.4 diameter has a roughness coefficient of 0.20. The channel has a uniform half flow. Compute the velocity. So it has the Froude number of compute the velocity, and it has a Froude number of 0.50. This is the circular aluminum, and we have the B equals 2.4 meters. So we need to find the velocity, but the formula that we need to use is the Frog number, which is we have Fn equals to V over the square root of gravity times A over B, which we have the Frog number is, we need to find first the area. So area is equal to pi times 2.4, this is the B, squared over 4 times 2. So the area is that we came to have an answer is equal to 2.26, and for the B is 2.4. So, magagamit na nato ang Frog number nga formula, which is ang this a given natin is 0.50 sa Frog number equals to V over ang gravity nga 9.81. Then substitute lang 2.26 ang B, then ang A, then ang B is 2.4. So calculate that. So we came up with an answer of velocity equals 1.52 meter per second. For number 36, the bottom width of a trapezoidal canal is 2.5 meters, and its sides are both inclined at 60 degrees with the horizontal. Water flows at a depth of 3 meters. The slope is S is equal to 0.0008, and the roughness coefficient is 0.03. Find the discharge using the Cheese's formula. So the Cheese's formula is we need to have a formula of cutter coefficient C. So the formula is C equals 23 plus 1 over M plus 0.00155 over S all over 1 plus N over the square root of the hydraulic radius times 23 plus 0.00155 over the slope. So we have our N, which is 0.03, substitute lang nato, plus 0.0015, and then the S is we have 0.008 over 1 plus 0.03 square root of, just the R nato is 1.347 times 23 plus 0.00155 over 0.008. So we have an answer of C is equal to 35.43. For number 37, the flow rate of 2.1 cubic meter is to be carried in open channel at a velocity of 1.3 meter per second and at a roughness coefficient of 0.020 meter. Between the slope, the cross-section is rectangular with depth equal to 1/2 its width. So we have here the figure, rectangular sections. We have the B, the base, and the depth. So ang ingon dali is 1/2 of its depth. Ang 1/2 of its depth, so D is equal to B over 2. So first, we need to find the area. So we have the discharge of 2.1 times area times ang velocity, which is 1.3. So you calculate that, we came up with an answer of area is equal to 1.615 square meter. So if mo ni times ang base times D, so D. So we have the area of 1.615 equals 2D. So we came up with the answer of D, which is 0.898. And then the next is we need to find the hydraulic radius. So first, na naman tayo A, no? So ito pangitaon is ang perimeter. So perimeter is equal to 2 times 0.898, which because this is the D, 2 times 0.898 plus 2 times 0.898. So perimeter is equal to 3.592 meters. So na tayo area, na tayo perimeter. So we can solve the hydraulic radius, which is R is equal to 1.615, which is the area, and then the perimeter over 3.592. So the answer for the hydraulic radius is 0.449. So the last but not the least formula is we have B equals hydraulic radius raised to the power of 2/3 times the slope raised to the power of 1/2 over N. So we have the hydraulic radius, which is 0.449 raised to the power of 2/3. Then ang pagipangita is ang vertical or ang slope, which is S is equal to 1/2, and then our over our N, which is 0.20, and then we have the velocity of 1.3 meter per second. So to calculate that, we can came up with an answer of the slope is equal to 0.00197. For number 38, for a wide open rectangular channel, if the vertical velocity equals 6 meter per second use the critical depth equals 3.67 meters. Compute the critical flow if the width of the channel is 3 meters or velocity equals 6. So this is the rectangular channel. We have the width which is 3 meters and the critical depth which is 3.67. So we need to find the critical flow. So we have a formula here which is equal to Q is equal to area times velocity, where area is 3 times 3.67 times the velocity of 6. So the answer is Q is equal to 66.06 cubic meter per second. So for number 39, a rectangular channel has a width of 4 meters and carries a discharge of 3 cubic meter per second. So we have a coefficient of roughness which is 0.0186. Compute the minimum specific energy. So this is our rectangular channel which has a width of 4 meters and then a critical depth of 0.386. So this is our solution. So our formula is Q equals the discharge over length, which is we have the discharge which is 3 cubic meter per second, and then the length which is 4. So 3 divided by 4, so we have the answer of 0.75 cubic meter per second per meter. So to get the critical depth, we have the formula, the cube root of Q squared over the G, which is the gravity. So na naman tayo Q there, which is 0.75. So cube root of 0.75 squared over the gravity, 9.81. So our critical depth is 0.386. And then we need to find the minimum specific energy. So the minimum specific energy equals 2/3 times the critical depth, which is our critical depth is 0.386. So substitute lang ari. So 2/3 times 0.386. So the answer is for the specific energy is 0.578 meters. So for number 40, a rectangular carries a discharge of 10 cubic meter per second for a width of 4 meters. Find the critical depth. So we have our solution for the critical depth. DC equals to cube root of Q squared over G, which is the gravity. So we need to find first the Q, which is, we have 10, which is the Q, 10 cubic meter per second, and our length, our width, which is 4. So 10 divided by 4, 2.5. So we have our Q. So substitute the Q here. So cube root of 2.5 squared over the gravity, which is 9.81. So to calculate that, we came up with an answer of 0.86 meters critical depth. For number 41, a rectangular channel 10 meters wide carries a 60 cubic meter per second when flowing 3 meters deep. What is the specific energy? So we have 10 meters wide, then 3 meters depth. So we have the solution. So we need to find first the velocity. So we have the formula of Q is equal to area times velocity. So we have our Q, which is 60 cubic meter per second. Substitute ng ari. And our area, 10 times 3, then the velocity. So to calculate that, so velocity is equal to 2 meter per second. But we need to find the specific energy. So the formula to find the specific energy is H is equal to V squared over 2G plus D, where our V is equal to 2 squared over 2 times the G, which is the gravity, 2 times 9.81 plus the depth, which is the 3. So 2 squared over 2 times 9.81 over 2 times 9.81 plus 3. So the answer for the specific energy is equal to 3.20 meters. So for problem number 42, a cylindrical tank 4 meter in diameter and 10 meter high contains 6 meters of oil with a specific gravity equals 0.9 and 4 meter of water. An orifice of 100 millimeter diameter is located at the bottom with CC equals to 0.62 and CV equals 0.98. Compute the rate of flow on the orifice in liter per second. So we have our cylindrical tank here, which is the oil and the water, and then their height, and then the diameter. So first, we need to find the height. So the solution is, we have 4 plus 6 times the specific gravity 0.9. So the answer for the H is 9.4 meters. The next one is we need to find the Q. or the Q. So Q is equal to CA square root of 2GH, where is the C is equal to 0.62, and then the A for the area is 0.98. So 0.62 times 0.98 is equal to 0.608. Then for the formula of Q is equal to CC times CVA square root of 2GH, which we have the CC 0.608 times pi over 4 multiplied by 0.10 squared square root by 2 times 9.81 times 9.4. So we have the answer 0.065 cubic meter per second, but we need to convert it into liter per second. So 0.065 cubic meter per second is equivalent to 65 liter per second. For number 43, a vessel containing oil with a specific gravity of 0.70 moves upward in vertical path with an acceleration of 8 meter per second squared. Find the intensity of pressure at the point in the oil 1.2 meters beneath its surface. So this is our figure, which we have the A is equal to 8 meter per second, and then the H is 1.2, and then the height is 2.4 meters. So we have a formula here. Pressure head over unit weight is equals to H times 1 plus A over dg or the gravity. So PA over unit weight equals which the H is 1.2 times 1 plus which is the A is 8 over 9.81 gravity. So 9.81 times 0.70 times 1.2 times 1 plus 8 over 9.81. So we came up with the answer of PA equals to 14.96 kilopascal. For problem 44, an orifice at the bottom of a square tank has a cross-sectional area of 0.004 square meter. The tank has a cross-section of 2 meter by 2 meter. If it takes 1,907 seconds to empty the tank, contains water at a height of 6 meters, find the value of C. So you have 2 meter by 2 meter, then the height is 6 meters. So we have the solution, so we need to find the value of C. So our formula is T equals 2AS times the square root of H1 minus the square root of H2 all over CA square root of 2G. So which is the time, not the time na 1,907 equals 2 times the area 2 times 2 times the square root of H1 which is the 6 plus the square root of H2 which is 0 all over times the CA which is 0.004 times the square root of 2 times 9.81. So the answer for the value of C is equal to 0.58. For number 45, a 300 millimeter cast iron pipe of length 500 meter carries 0.3 cubic meter per second between two constant head reservoir. Assuming F equals 0.021 for all pipes, compute the difference in elevation between the two reservoirs. So this is our figure. So we have the length of 500 meters, the diameter of 300 millimeter. So our formula you need to be used is head loss is equal to 0.0826 FLQ squared over D raised to 5. So substitute for the constant 0.0826. Then the F is which is 0.021. The length is 5,000 times the Q which is 0.3 squared over the diameter which is 300 mm, convert to meters, so 0.3 raised to 5. So the answer for the difference of elevation between the two reservoirs is the height is equal to 321.22 meters. Okay, so for problem number 46, through a rusty iron pipe 150 mm in diameter, the observed velocity is 2.439 meter per second. At a section A on the pipe, the measured pressure head is 27 meters, while at B is 30 meters. Further on, where the pipe is 1 meter below A, the pressure head is found to be 23 meters. Compute the head loss between A and B. So this is our figure. This is where the A and B, and then the height is 1 meter, and then from A to B we have the 30 meters and our diameter which is 150 millimeter diameter. So this is our solution for the problem 46. So we have VA squared over 2G plus the pressure head over the unit weight of water plus ZA equals to BB squared over 2G plus the pressure head over unit weight plus ZB plus the head loss. So cross out everything. So VA is equal to VB equals 2.439 meter per second. Then divide 2.439 over 2G plus the pressure head 2.7 plus the ZA which is 1 equals ang VB 2.439 squared over 2G plus 23 plus 0 plus the head loss. So the head loss equals to 28 minus 23 is equal to 5 meters. So for problem 47, a small ingot and platform rest on a steady water jet. If the total weight supported is 825 Newton, what is the jet velocity? So this is the figure. Water jet has the 60 mm diameter. So our solution is, first we need to have the F which is equal to 825. So F equals to Q times W over G times the velocity. Then F 825 equals Q times the weight which is 1000 times V. So 0.825 is equal to QV. So 825, so we have our 825 is equal to QV. So Q is equal to AV. And the area is pi over 4 times 0.06 squared V. So Q is equal to 0.0028 volume. Then the volume will be 17.1 meter per second. For problem number 48, compute the horizontal component of the water acting on the deflecting blade shown. So this is the figure. So we need to compute the stationary. So the solution is the summation of Fx equals to m times V2y minus V1x. So negative Rx equals to density times area times the volume 1 times the negative V2y cosine 60 degrees minus V1. So negative Rx, the density which is 1000. The area is pi over 4, 0.4 squared times the velocity is 40 times negative 40 cosine 60 minus 40. So the answer for the Rx is equal to 3016 Newton. So for problem number 49, the head loss of a cast iron pipe 900 meter long is 4 meters. Compute the diameter of the pipe if it carries a discharge of 0.8 cubic meter per second using Darcy formula with F is equal to 0.02. So the formula of Darcy is the head loss equals 0.826 FLQ squared over D raised to 5. So substitute lang. So we have the head loss of 4 meters, then the 0.0826, and then the F which is 0.02 times the length which is 900 times the Q which is 0.8 raised to the power of 2 all over D raised to 5. So the answer for the diameter is D is equal to 0.0145 meters. For problem number 50, the last but not the least problem, so the cross-section of a right triangular channel is shown with a coefficient of roughness which is n equals to 0.012. The rate of flow is 4 cubic meter per second. So this is the triangular channel. So we have here the slope current of 2 DC and then the critical depth and then the theta which is 45 degrees and 45 degrees. So calculate the critical depth. So we're solution. So A is equal to 2 DC times DC over 2. So A equals to DC times DC, DC squared. Where B is equal to 2 DC. Then Q squared over G equals to A cubed over D. We have the Q for 4 squared over the gravity over 9.81 equals the A cubed DC squared raised to the power of 3 over V which is 2 DC. And then DC raised to 5 is equal to 3.26. So the final answer will be the critical depth equals 1.267 meters.